And I believe all of you know what is inventory, right? Inventory is something that we keep or that we store. So anything that a factory is keeping or holding or storing is called inventory. In the first hours, I think there will be a lot of talking from me because I need to discuss and explain a lot of concepts to you. And then hopefully in the second hour, we will go into the mathematical model, or the calculation part. Okay, let me begin by showing this photo. And hopefully from here, you can understand better what is the role of inventory. So what this photo says, it says lower water equals to lower inventory, and because of that, it helps to expose problems. Now, you see in this photo, there is a boat or there is a ship, right? Sailing on the sea. So this is the sea level. And then below the sea, there are rocks, right? Rocks, there are plenty of rocks. So of course, common sense will say that we want the ship to actually sail well above the sea level, or in other words, you want the sea level to be high enough, right? If the sea level is high enough, then the boat can sail smoothly, yeah? But if the sea level is too low, then the boat may hit or bump into the rocks or the stones. So in this case, the sea level is actually the inventory level. The sea level is equivalent to the inventory level, and all the rocks below the sea are actually the problems. Okay, the problems in a manufacturing company, such as defective materials, unreliable suppliers, poorly trained workers, and so forth. Okay, now if you understand this, then there are actually two inventory practices in the industry. Okay, the first practice is company would like to keep a lot of inventory. They want a high inventory level. So in other words, they prefer the sea level to be high. Yeah? Now, when the sea level is high, then we will not be able to see all the stones, right? So basically, the sea level has hide or cover all the stones. So same case, in manufacturing companies, if the company is keeping a high level of inventory, some company prefer to do this because it will help the company to hide all the problems. Okay, because we will not be able to see where are the problems if the inventory is enough, or if the inventory level is high enough. Okay, it's just like the sea lah. If the sea level is high, it will hide all the stones. So in the manufacturing plant, similar case apply. If the company is keeping high level of inventory, then it will help the company to hide all the problems. Okay, such as defective materials and reliable suppliers, the company will not be able to see them. And in fact, with a high level of inventory, it may sometimes help the company to solve all these problems. Okay, so that is the first practice. The second practice is some companies prefer low inventory level. So in other words, they prefer the sea level to be low. So when the sea level is low, then all the stones will be exposed. All the rocks will be exposed. So in other words, all the problems will be exposed. So company that keeps low level inventory normally knows where are their problems. Okay, because the problems cannot be hide anymore, they can see clearly where are their problems. Okay, they will know whether they have defective materials or not. They can see clearly whether the suppliers are reliable or not. And this is what sometimes a company prefer. They prefer to know where are their problems, so that after they know their problems, they can take effort to actually solve the problems. Okay, so this is the overall message that this photo trying to convey to you. If lower water level, it means lower inventory level, and as a result, it helps the company to expose where are the problems. In the textbook, okay, there is a very interesting case discussing how Amazon has been very successful, and one of the reasons is because of their inventory management practices. I'm sure everyone knows Amazon, Okay, if you do not know Amazon, then maybe you're not living in the same world as we are living, Right? Amazon is owned by Jeff Bezos. Okay, he's now the second richest man in the world. The first richest man is now Elon Musk from Tesla. Okay, if you know the history of Amazon, Amazon actually started as a virtual company. Okay, without any inventory, with no warehouses, with no overhead costs. Okay, only computers taking orders to be filled by others. But as time passes, Amazon has grown and it has transformed the company into a world leader in warehousing and inventory management. So Amazon has been so successful nowadays because there are many reasons, of course. One of the reasons is because of their good inventory management practices. Now, Amazon has very, very large warehouses in the US and throughout the world. Okay, when I say very large, means it is really very large. Uh, if you read articles from the internet, okay, the average size of an Amazon warehouse is about, I think, 1 million, 1 million square feet. Okay, now how big is 1 million square feet? It is like, I think, 15 to 17, okay, 15 to 17 football field. So you can imagine how large is the warehouse. The largest warehouse in Amazon, I think, is more than 3.5 million square feet. Okay, that is equivalent to, I think, more than 60, more than 60 football field. Right, so to manage those inventory in such a large warehouse is very challenging because the warehouse is too large, it's so large. Even finding an inventory in the warehouse is so difficult. Okay, so therefore you will see that Amazon actually apply a lot of high tech, a lot of sophisticated technology to actually store the inventory, to keep track of the inventory, and to retrieve the inventory. So if you're interested, you can read this case in the textbook. Okay, for example, it says items are placed on a conveyor, barcode scanners scan each item for 15 times to virtually eliminate any errors. Okay, there are other practices you can read. Okay, once an order is placed, order will arrive at customer within 1 to 2 days. Okay, in the US. Right, so what is inventory management? What is the objective of inventory management? So the objective of inventory management is to strike a balance between inventory investment and customer service. Now, what is the meaning of inventory investment? It means how much inventory we should keep. What is the quantity of inventory that we should keep? And also, what is the cost of keeping that inventory? So that is known as inventory investment, means how much quantity and cost we have to invest in the inventory. And customer service basically means fulfilling the customer order or customer demand. Right? So the objective of inventory management is actually to strike a balance between how much we need to keep, how much inventory we need to have, and the cost of keeping the inventory with fulfilling customer demand or customer order. Importance of inventory. Inventory is actually one of the most expensive assets of many companies, representing as much as 50% of the total invested capital. Now, in manufacturing plants, of course, there are many assets. Yeah, the building is an asset, the machines are assets, okay, warehouses are assets, and inventory are also a type of assets. Okay, we have tangible and intangible assets, right? So inventory could either be tangible or intangible. So inventory is a kind of assets, and it is one of the most expensive assets, basically representing as much as 50% of the total invested assets. So operations managers must balance between achieving inventory investment and fulfilling customer service. I will explain that. Okay, what is the functions of inventory? Why do we need inventory? First, to provide a selection of goods for anticipated demand. So in other words, inventory helps us to fulfill customer demand. Okay, and to separate the company from fluctuations in demand. In other words, to protect the company from fluctuations in demand. I think I already given you this example. Look at oil and gas. Currently, oil and gas is in very high demand, okay, due to the war between Russia and Ukraine. Okay, so imagine if a company in the past, a company in the past has kept or has stored a lot of oil and gas, then now the company will certainly be able to uh, cope with the demand because they have already stockpiled a lot of oil and gas in the past. So this is the meaning to protect a company from fluctuations in demand. Second functions of inventory is to decouple or to separate various parts of the production process. Now, if you look at a product, before a final product can be produced, it has to undergo various production processes. Okay, so each production process actually produce something. Okay, which could be a semi-finished product or work in progress or work in process. Right? Each production process will produce a work in process or semi-finished product. Semi-finished product means not fully finished yet, not fully completed yet. It is only semi-finished. So these semi-finished products will have to undergo various processes until the final product is completed. So in other words, by looking at the work in process or semi-finished product, we can easily trace back. Which is the production process that actually produced the work in process or semi-finished products. So in other words, this helps to identify or separate various parts of the production process. Okay, number three, to take advantage of quantity discounts. So if you order inventory in a large quantity, sometimes the supplier may give you discount. Okay, sometimes. So that's a function of inventory. That's a function of having a high level of inventory because you want to take advantage of quantity discount. And the fourth function is to hedge against inflation. Okay, to hedge against inflation is to protect against inflation. I think this is similar to point number one that I've explained. Okay, types of inventory. Um, Raw material can be inventory, work in process or WIP can also be inventory. Finished goods are definitely inventory. In fact, spare parts that we keep for maintenance, for repairing machines, for operating a machine, those are also inventory. Let me give you one example. For example, we are making a plastic bottle. Okay, let's say a mineral water plastic bottle. So anyone can tell me this plastic bottle is produced using which process or what process? Anyone knows? Okay, plastic bottle. What is the manufacturing process that make plastic bottle? What is the name of that manufacturing process? Molding. Okay, correct. Okay, plastic bottle is normally produced through injection molding process. Okay, so what is the raw material making this plastic bottle? The raw material will be plastic. Okay, plastic or thermoplastic, such as polypropylene, polyethylene, okay, nylon plastic. Okay, so all this plastic will be heated and melted and then injected into a mold, okay, in the injection molding machine. So after being injected, uh, the thing will have to be cooled off. Okay, once cooled off, the plastic bottle is created. So we open the mold and we take out the plastic bottle. Okay, now, so the plastic in this case is the raw material. Okay, but the plastic bottle produced through the injection molding machine is actually a work in process. Okay, it's not complete yet because a complete uh, water bottle needs to have the cap, right? Not only the body of the bottle, but also the cap of the bottle. Right? So if the injection molding machine only produce the body of the bottle, then that is known as the work in process. So work in process means something that has undergone some process or some changes, but not completed yet. So the body of the mineral bottle or plastic bottle is only a work in process because it doesn't have the cap yet. Okay, once you have the cap and once we assemble it into the body of the plastic bottle, then it becomes a finished goods. Okay, so finished goods are completed products, completed goods waiting to be shipped to the customers. Right? So inventory can be raw material, can be work in process, can be finished goods, and it also can be for maintenance, repair, and operating spare parts. For example, injection molding machines. Company will be keeping spare parts of the injection molding machines. For example, the company may be keeping spare parts like the mold itself, the bolts, the nuts, the spring, the spindle, the plate. Okay, all these are spare parts for maintaining and repairing the machines, the injection molding machine. So those spare parts are also categorized as inventory. Yeah? Okay, if you look at the raw material inventory flow cycle, this is just to give you an understanding. Okay, let's say there is a manufacturing plant that process wood. Okay, so the raw material will be tree trunk. So these are tree trunks. So once it arrives at the factory, probably the first thing that has to be done is to inspect the raw material. So the raw material will be waiting for inspection. The operator will come and inspect the raw material. If everything is okay, then you still have to wait. Okay, wait to be transported to another department. So let's say the forklift comes, so the forklift come and transport the tree trunk to the production department. Okay, so transportation will consume time, so you have moving time here. So once it reached the production department, maybe it has to queue or wait again for the operator to come and process the raw material. So imagine the operator has come, but then the operator cannot process it yet because the operator will have to set up the machine. In this case, the cutter. So the operator set up the cutter, so setup time is involved, and when everything has been set up, then only the production process will begin. The cutting process will begin. So the wood or the tree trunk is being cut. Okay, they are cut into to pile wood, into piles of wood, which is called plywood, I think. So this is plywood. Now, so if you look at the entire life cycle, only 5% of the time is spent on the real production process, which is the cutting process. The other 95% of the time is actually spent on transporting, checking, coordinating, and managing the inventory. Okay, because from this phase, from this phase until this phase, okay, the tree trunk is still in the form of raw material. It's a raw material inventory. So 95% of the time is spent actually managing the inventory. And because so much time is actually spent on managing inventory management become important and has to be given attention by every company. Okay, so let's go to inventory management now. Every company has a lot of inventory. Okay, already said it could be raw material, work in process, finished goods, spare parts. And in fact, raw material also, there could be many types of raw material. Finished goods also, there could be different models, different types of finished goods. Right? So, common sense will say that a company should focus more attention to manage inventory, which are more important, right? And give less attention on the inventory, which is less important, right? So, if you understand this, then the first thing that a company should do to manage inventory is first to classify the inventory. Okay, to classify the inventory into different classes based on their values or based on their importance. Okay, because once we know which inventory is more important, then we can give more attention to manage that inventory which is more important. Right? So managing inventory deals with how inventory items can be classified. So this is what I'm trying to explain. You have to first classify the inventory first. So there is a method which is called ABC analysis that helps us to classify inventory into three different classes. So it is called ABC analysis. So this technique categorizes or divides the inventory into three classes. Okay, based on their annual dollar values or annual dollar volumes. Okay, so we have three classes: class A, class B, class C. Class A are inventory which has the high annual dollar values. Class B are inventory having medium annual dollar value. And Class C are inventory with low annual dollar values or volume. So the purpose is to know which inventory belongs to which class, because after knowing that, we can establish policies that can focus on the few critical parts and not the many trivial ones. So Class A is actually known as the critical inventory. So attention should be paid or should be focused on managing Class A inventory. Class B and C are known as the trivial ones. Okay, you know what is trivial, right? I think you studied in quality before, right? Okay, I remember you should have studied in quality before. Trivial means common lah. Okay, or how do I say it? General. Okay, trivial. Not critical, but common one or general one. So the purpose of classifying this is so that we can know which one is class A, and class A is critical, so we pay more attention to manage class A. Class B and C are trivial, so we can pay less attention. Right? Okay, so this is one example how we can do ABC analysis, so please pay attention. So imagine in this question, you are given 10 stock items. So imagine in the inventory list there are 10 items, or in the warehouse there are 10 type of inventory. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So normally column 3 will be given. Okay, column 3 is the annual volume in terms of quantities, in terms of units. Okay, so for stock item 1, the annual quantity is 1000. For item inventory 2, it is 500 and so forth. Okay, so I hope you understand this. So it means that on an annual basis, on a yearly basis, the company will have 1000 units of item 1 or inventory 1. The company will have 500 units of item 2 on a yearly basis. Right? Okay. And then column 4 will also be given. This is the value of the cost of the inventory items. It's the unit cost. Unit cost means cost per unit or the value per unit for each inventory item. So for inventory item 1, the cost per unit is $90. For item 2 is $154 and so forth. Okay, given the data for column 3 and column 4, normally you will be asked to calculate column 5. Column 5 is actually the annual dollar value, so the annual dollar volume. So an annual dollar value is just the annual quantity multiplied with the unit cost. Okay, as simple as that. So the annual dollar values for inventory item 1 is 1000 times $90, so become 90,000. For item 2 is 500 times 154, so it is 77,000 and so forth. Okay, once you have calculated this, the next thing you have to do is you have to arrange them in descending order. Okay, make sure you arrange the inventory items in descending order following their annual dollar values. Okay, because later we want to classify them into A, B, and C. If you don't arrange them in descending order, you cannot classify them. So make sure you arrange them in descending order. Means the largest one at the top, the smallest one at the bottom. Okay, and then after that you can calculate the total. Okay, this total is used later to calculate the percentage in column 6. So in column 6, you have to calculate the percentage of annual dollar values. Okay, so for example, how we get 38.8%, it's just 90,000 divided by 232,057. You get 38.8. Okay, how do we get 33.2? It's just 77,000 divided by 232,057. So we get 33.2%. Okay. From here, we can then group them into class A, class B, and class C. Now, you may ask me, okay, why the first two items are in class A, why the next three items are in class B, and so forth. Okay, listen carefully. There is actually no strict rules. There is no strict rule saying that which one is in class A, class B, or class C. Okay, but there is a general rule. There is a general rule that applies. Now, this general rule says that about 20%. Okay, about 20% of the total inventory items should belong to class A. Okay, so if we take 20% times 10, so it means 2. 20% times 10 means 2. So it means the first two most valuable inventory items will be classified as class A. So class A accounts for about 20% of the total inventory item, and class A will also account for about 70 to 80%. 70 to 80%. Okay, of the annual dollar values of the inventory. Okay, and class B normally account for 30% of the total inventory items. So 30% times 10 means 3 items. So it means the next 3 items will be categorized as class B. Okay, and at the same time, class B will also account for about 15% to 25% of the annual dollar value or annual dollar volume. Okay, that's why if we calculate this, it is about 23%. So it falls into this range, 15 to 25%. And class C normally accounts for 50% of the total inventory items. Okay, therefore 50% times 10 is 5. Therefore we have 5 items here. And class C will also normally account for 5% of the annual dollar values. Okay, so that is a general rule being applied. So I repeat, class A, you may want to write down. Class A normally accounts for 20%. 20% of the total inventory quantity or total inventory items. And it will also account for about 70 to 80% of the annual dollar values. Class B will account for about 30% of the total inventory items and account for about 15 to 25% of the annual dollar values. And class C normally accounts for 50% of the total inventory items and 5% of the annual dollar values. So this is how we classify the inventory items into class A, class B, and class C. Okay, is that clear? Any question? Okay, it is very hard to get exactly 70% or 80% or exactly 15% or 25%. Normally it falls within this range. Okay, that's why I said there is no strict rule, but there is only a general rule that applies. Okay, for example, if you calculate, you cannot get 5% here. Okay, you get about 4.8 or 4.9%. That will also do. Okay, so only the general rule of thumb apply. Okay, now if you plot this into a chart, it will look something like this. Okay, so the y-axis is the annual dollar values. Okay, and the and the x-axis is the percentage of inventory items, the percentage of the quantity. So we have class A here, class B here, class C here. Now, this look very similar to Pareto chart, correct? Pareto chart. So what does Pareto chart say? Pareto chart is based on this 20-80% concept, right? Okay, if you remember Pareto chart that you learned in quality, it says what? It says that 20% of the items or 20% of the problems is worth 80% of the values, right? That is the Pareto principle, 20%, 80% rule. 20% of the quality problem, or 20% of the items account for about 80% of the value. Okay, so this is what Pareto asks us to do. We should focus on the 20%. Okay, Pareto's chart says that we should pay attention to the 20% of the items or 20% of the problem, because if we can solve 20% of the problem, we are solving 80% of the value. Is that clear? So similarly, for inventory, once you have got this, it looks just like Pareto chart. We have A items, B items, C items. So if you look at A items, as I said, it's about 20%, right? It's about 20%. So in this case, it's about 20% of 15 here, and the value is 80%. So it's 2080 here. So this is known as the critical field, critical one. Okay, B and C are the trivial one. So once you understand this concept, so it means that in inventory management, we should focus our attention to manage this class A inventory. Okay, this class A inventory is not many, it only accounts for about 20%. Okay, but if we can manage this 20% of the inventory well, then we are like managing 80% of the total inventory value. Okay, this is what I'm trying to say. So the trivial one, you can pay less attention because the value are not high. Okay, but the class A items have 80% of the value. So if we can manage properly the A items, the class A items, then it means we are managing about 80% of the total value. I hope you understand, Okay, next. In ABC analysis, the most common criteria used is the annual dollar values, annual dollar volumes. Okay, this value over here. Sometimes other criteria can also be used, such as shortage cost or holding cost, or number of engineering changes, or number of delivery problems, or number of quality problems. Okay, or it could be percentage, percentage of delivery problems or percentage of quality problems. Okay, but most textbooks, as I've seen so far, usually they use annual dollar values. Okay, next. So based on the ABC analysis, as I said, we should focus on managing Class A inventory. So from there, policies can be developed or policies can be employed to actually manage Class A inventory. So what are the examples of policy that can be developed? For example, it says more emphasis on supplier development for Class A items. Okay, you know, Class A inventory items are very important. They have high values. So we want good suppliers that can deliver good quality products or good quality inventory for Class A inventory. So to ensure that suppliers can deliver good quality inventory, we may have to engage in supplier development program. Make sure our suppliers are capable of delivering high quality Class A inventory items. Second type of policy that can be employed is tighter physical inventory control for Class A items. Okay, again, Class A items are important inventory items with high values, so they require tighter physical inventory control measures. Okay, for example, a company may hire more security guards to look after the Class A items. Okay, the Class A items may be stored in a more secure place, or the company may insure Class A items by buying more insurance. Okay, or they may control these inventory items, Class A items, using more high-tech technology, more sophisticated technology. And number three, more care should be given in forecasting Class A inventory items. Okay, again, Class A items are important items, so they need to be forecasted accurately. So more attention should be given to forecasting Class A inventory items. Okay, another important thing to manage inventory is we have to keep accurate records of inventory items. So accurate records are a critical ingredient in production and inventory systems. So to ensure we are keeping accurate records of inventory, we have to continuously keep track of receipts, keep track of any inventory that's being received Means you have to keep track of the incoming inventory. At the same time, we also have to keep track of any outgoing inventory. Okay, inventory which is being delivered to customers. Okay, and this keeping track thing can actually be done using technology. Either semi-automated technology or fully automated technology. Okay, such as barcode, scanner, RFID technology, sensors, IoT, and so forth. Right, so this is what I've said. Incoming and outgoing inventory record must be kept accurately. Okay, that's the first thing. Stock rooms should be secured. Okay, and record accuracy is important. Keeping accurate inventory record is important because it helps us to make precise decisions about ordering, scheduling, and shipping. Okay, let me see what time now. 11:40. Okay, let's continue with cost. You have to understand this type of cost first before I can go into the mathematical model. Okay, this one I think I've explained before, some part of it in the previous chapter. So there are a few elements of inventory cost. First is called holding cost. Okay, holding cost is the cost of holding or carrying the inventory over time. Okay, so basically it just means the cost of storing the inventory lah. Okay, the cost of holding or carrying it or storing it is known as holding cost. Okay, what about ordering cost? Okay, another element of the inventory cost is called ordering cost. Ordering cost is the cost of placing an order or receiving goods. For example, we are trying to place an order from our supplier, so we call our supplier to place an inventory order. Okay, so that telephone bill, because we call the supplier, right? So that telephone bill is actually part of ordering cost. Or the cost of the paperwork. For example, to place an order, we have to issue an invoice, and then later we get the receipt. So the paperwork cost is also part of ordering cost. Right? In fact, the transportation cost also is also part of ordering cost. And what about setup cost? Setup cost is the cost to prepare a machine or process for manufacturing an order. So setup cost is the cost incurred for setting up a machine or process. Now, please understand ordering cost and setup cost. Okay, these two costs will be relevant for different company. Now, if the company is not buying the raw material, if the company is making the raw material themselves in-house, then no ordering cost will be involved. So only setup cost will be involved because the company is making themselves the raw material. So if the company is making the raw material themselves, they have to set up their machine and process to make the raw material. And after that, the raw material produced will be delivered to another production department to make the finished product. So if that's the case, setup cost will be relevant to the company. Okay, but most of the company do not do that. Most of the company prefer to buy the raw material from a supplier. So if the company purchase the raw material from a supplier, then ordering cost will become relevant. So it all depends on the actual operation of the company. So it's either setup cost or ordering cost. Either one. It depends whether the company make the raw material in-house or they purchase the raw material from the supplier. I hope this is clear. Because later the textbook use these two terms interchangeably. Sometimes I call it setup cost, sometimes I call it ordering cost. So I'm worried that you get confused because these are two different costs. Okay, but they are treated similarly because it depends on what the company practice is. I hope that is clear. Okay, holding costs. The textbook gives some examples of holding costs. Okay, for those who do not understand what is holding cost actually consists of many elements. So to hold an inventory, to store inventory, okay, company may incur housing costs, material handling costs, labor costs, investment costs, pilferage, space, and obsolescence costs. Okay, let's talk about the first one, housing costs. So to hold or to store inventory, we need a warehouse, right? In other words, we need a space. So a company either rent a warehouse to store the material or they build their own warehouse to store the material, to store the inventory. Correct? So if the company rent a warehouse, then rental cost will be involved. So rental cost is part of housing cost. And if the company built its own warehouse, then after building it, the warehouse will depreciate over time, right? So depreciation cost will be involved. So depreciation is also part of housing cost. And of course, the warehouse has to be operated, correct? You need electricity to operate the warehouse. Okay, overhead costs. Uh, Sometimes aircon has to be there because the product has to be kept in room temperature, or some products require to be refrigerated. So refrigeration cost is involved. So all these are under operation costs. Okay, taxes. Company have to pay taxes, insurance. Okay, inventory and the warehouse has to be insured. Has to be insured against damage, against fire, against theft, against natural disaster. So company have to purchase insurance. So all these are part of housing cost. So housing cost is an element of holding cost. Another element of holding cost is material handling cost. Okay, all the inventory that are stored in the warehouse has to be handled. Correct? We have to load them and unload them from the storage racks. We have to load them and unload them from the lorry. Okay, and normally to do that, we require a forklift. Correct? So the cost of the forklift or the cost of the equipment is part of material handling cost. So this is one example of material handling cost. And of course, labor costs are involved. So labor cost is also part of holding costs. Okay, because we need operator to actually unload or load the inventory. We also have to hire security guards to look after the warehouse. So all these are part of labor costs. Okay, and then investment cost is also part of holding costs. Okay, to build a warehouse, company have to borrow money from the bank to build a warehouse. So loan is involved, mortgage is involved. So all these are part of investment cost or borrowing cost. And then pilferage cost, obsolescence cost. Okay, what is pilferage? Pilferage means what? Means theft. Theft means a thief steal a product. Okay, means stealing a product. Pilferage. Okay, so if the product is being stolen by a thief, then certain costs will be incurred, will be involved. Okay, or if a company keep a product for a very long time until the product or the inventory become obsolete. Obsolete means out of date. And so in that case, obsolescence cost will be involved. Okay, so pilferage costs, obsolescence costs are also part of holding costs. And statistics have shown that holding costs actually account for about 26% of the total inventory cost. Okay, it says here holding costs can vary, can be different depending on the business location and interest rates, but generally it is greater than 50%. Okay, and for some high-tech and fashion companies, their holding cost could be greater than 40%. Okay, which is quite a lot. Okay, next concept that you have to understand is this: independent demand inventory items and dependent demand inventory items. Okay, what is independent demand? Independent demand demand for item. Okay, independent demand means the demand for item is independent of the demand for any other items in the inventory. Okay, let me give one example. Let's say a car manufacturer. Okay, a car manufacturer. So in the inventory list, there will be many types of inventory, right? Including the finished product, sub-assemblies, work in process, raw material, and so forth. Right? So for car manufacturer, the inventory will be the finished car, for example, the completed car. Okay, tires could also be inventory. Okay, wheels, engine block, engine, gearbox. Okay, transmission shaft. Okay, blah blah blah. and all the accessories. Okay, now if you look at completed car, completed car is the finished goods inventory. Okay, so completed car is actually an independent demand item. Okay, because the demand for completed car is independent. Independent means does not depend. The demand for completed car actually does not depend on the demand for any other items in the inventory. Correct, right? The demand for a completed car does not depend on the demands of tires, does not depend on the demand of wheels, does not depend on the demand for engine, gear, and so forth. The demand for completed car only depends on the demand from the end customers. All right. So therefore, completed car is an example of an independent demand. So to make it short, independent demand is normally for finished product. So I hope that is clear. Finished product is normally known as independent demand because the demand for finished product only depends on the demand from the end customers, and it does not depend on the demand for any other items in the inventory list. Okay, and what about dependent demand? Dependent demand means the demand for the inventory item is dependent upon, means it depends on the demand for some other items in the inventory. So dependent demand means the demand for item is dependent on the demand for some other items in the inventory. So look at here, tires are actually dependent demand. Why? Because the demand for tire depends on the demand for the completed car. Right? If there is a demand for 10 units of completed car, then it means we will need 40 tires. Right? If we need if we need 10 cars, if there's a demand for 10 cars, it means the demand for tires will be 40. Why? Because the demand for tires depends on the demand for car. One car has 4 tires, right? So tire is actually a dependent demand. Example of dependent demand. Because the demand for tire depends on the demand for some other items in the inventory, which is the completed car. Same thing, wheels, engine, gear, shaft, these are all dependent demand because the demand for all these items depend on the demand of the finished product. Anything that you don't understand? Is it clear? Okay, or you guys are sleeping already?
Clear that.
Okay, I hope it's clear. So now the reason I explain this to you is because later when you study the inventory models, okay, the inventory models are only workable for independent demand. Okay, so later you will study 3 models: EOQ model, POQ model, QD model, and a few more. So all these models are only to manage the inventory for independent demand. In other words, for the finished goods inventory. Okay, or inventory item that does not depend on the demand of some other items in the inventory. Okay, for dependent demand, you will learn it later in the following chapter on material requirement planning. Okay, this chapter, all the inventory models that you will learn is only for independent demand. Okay, we'll take a break. You want to take a break for 5 minutes? Or for me to continue so that I can complete earlier and I can let you go earlier? Okay, take a break lah, okay? I think someone has thumbs up, so take a break for 5 minutes. Please come back at 12 p.m. sharp. Okay, let's continue. It's already 12 p.m. Can I continue? Can I? I hope everyone is back. Huh?
Yes, yes.
Okay, so let's continue. Now, as part of inventory management, companies would like to know when they need to order, okay, and how much to order. So these are two questions. These are two questions that has to be always answered by companies. First is when the company should order their inventory, and second, how much, what is the order quantity. So to answer these two questions, okay, there are several inventory models that can be applied. So these are mathematical models. Okay, the first is known as economic order quantity EOQ model. This is the most basic model. Every student should know this. In fact, the formula also you should memorize it. Okay. Second is known as production order quantity model POQ, and third is known as quantity discount QD model. So today we have about 1 hour left, less than that. So I will try to complete the first model, EOQ model. Right. So before I show you all the mathematical formulas and things like that, okay, you must first understand the assumptions. The assumptions underlying this model. So to use the EOQ model, all these assumptions has to be valid. First, we must assume that demand is known. Okay, demand is constant and demand is independent. So independent, I already explained. Independent, what is that? Okay, and you must also assume that demand is constant. Now, normally demand is given on a yearly basis, and we assume that the quantity of the demand is constant. For example, 1,000 unit per year. Constant. We cannot say, oh, sometimes it's 900 unit per year, sometimes it's 1,005 per year, sometimes it's 2,000 per year. We cannot have that kind of scenario. We must assume demand is constant every year. So that is the first assumption. Second assumption is we have to assume lead time is also known as and constant. What is lead time? Lead time is the time between the time we place the order until the time we receive the order. That is lead time. Okay, lead time has many different definitions. If you look at the production process itself, definition of lead time is different because that is the production lead time. Okay, but the lead time here is the inventory lead time. So inventory lead time means the time from the moment we order the inventory, we place order on the inventory until the order is being received or when the order arrives. So that duration is known as the lead time. So lead time is known, means it's given and has to be constant. Third assumption, receipt of the inventory is instantaneous and complete. For example, we place an order of the inventory and the inventory is scheduled to arrive on day 10, on day number 10. Okay, and we place an order of 100 units of the inventory, scheduled to arrive on day 10. So on day 10, all the 100 units of inventory must arrive completely and instantaneously. Okay, we cannot say, oh, 50 units arrive on day 10, another 50 units arrive on day 11, and so forth. We cannot have such scenarios. So all the units being ordered must arrive completely at the same time, instantaneously. And the fourth assumption is quantity discounts are not possible. This is one of the limitations of the EOQ model. Quantity discounts are not possible. In practice, if we order larger quantities, suppliers will give discount. But in EOQ model, we just cannot consider discount. So discount is not considered in EOQ model. And number 5, in EOQ model, two costs will be considered, two costs will be involved. First is the setup or ordering cost. Second is the holding cost. Okay, that's why before this, I need to explain to you what is setup cost, what is ordering cost, and what is holding cost. And I already explained, setup and ordering costs are actually the same thing. because either the company need to set up the machine to manufacture the raw material in-house, or they purchase it from a supplier. If they manufacture it in-house, then setup cost will be relevant. If they purchase it from a supplier, then ordering cost will be relevant. So it's either one of these. And holding cost already explained just now in very great detail what are the elements of holding cost. So you should understand what is holding cost already. And assumption number 6, stock out can be completely avoided. Means we assume that there is no stock out. Means the stock level is always enough. And you also need to understand this cycle before I go into the model. Okay, this cycle is what we call the inventory usage level cycle. So imagine at the start of time, time 0, we have Q quantity of inventory in the warehouse. So let's say this Q quantity is the maximum inventory level. Okay, Q is a number. Let's say we have Q quantity of inventory in the warehouse. So as time passes, this inventory will be used, right? It will be used, it will be consumed, right? You will take it out from the warehouse to make your products, or you may take it out from the warehouse and send it to your customers. So it means as time passes, the level of Q will decline, will reduce. Okay, so we assume that the usage rate is actually linear because the line is a linear line. Now the slope of this line, the slope, the keturunan of this line, the slope of this line is actually the usage rate. Okay, later I'll explain more on this usage rate, but for the moment you just have to understand the slope of this line is actually the usage rate of the inventory. So as time passes, the inventory will decline, the level will decline until it reaches 0. When it reaches 0, we assume that the inventory level will be straight away replenished. It will be straight away top up, and it will reach back the original quantity, which is Q. Okay, so this is the moment where the order is being received. Once it reaches 0, we assume that the order has arrived, the stock level is being replenished and then top up to the original level. Okay, and then as time passes, the inventory will be used up. So again, the inventory level will decline, will reduce until it reaches 0, and then it will be replenished back. So this cycle will repeat and repeat and repeat and repeat. And because the maximum inventory level is Q, we can say that the average inventory level will be Q divided by 2. Please understand this. This average inventory level later will be used in the model. This is the average inventory level. It's just the Q, the maximum level, divided by 2. Okay, next thing you have to understand is this before I show you the mathematical models. So I already said just now, 2 types of costs are involved. One is the holding cost, the other is the setup cost. So if we plot the graph of the cost, annual cost or total cost versus the order quantity. Okay, so if we plot the holding cost, we will get a blue line like this. Okay, does it make sense? It shows that the holding cost is increasing with the order quantity. So if you order less, if your order quantity is small, so it means we have to keep less inventory, right? So therefore you have smaller holding costs. But if our order quantity is large, it means that we have to hold or store or carry more inventory, right? So therefore holding costs will increase. Okay, holding costs will increase. So I think this makes sense lah. So as order quantity increases, holding costs will increase. And the increase is in a linear way. Okay, what about setup or ordering costs? If we plot setup or ordering costs versus order quantity, it will look something like this. It will decline. Okay, anyone knows the reason why it is like this? The reason is quite simple. Let's say we order less quantity. Okay, let's say we start here. Order quantity is less. So if the order quantity is less, it means we have to order more frequently, correct? So if we order more frequently, ordering cost will be high. But if the order quantity is large, then it means we don't have to order so frequently. The ordering frequency can be reduced. When the ordering frequency is reduced, the ordering cost can be reduced. Alright, example, let's say demand for the inventory per year is 12,000. Okay, every time we order only 100 units. So it means in 1 year, if we order only 100 units, in 1 year it means we have to order 12 times. Okay, so imagine every time you order, ordering cost will be involved. So the more frequent you order, the higher the ordering cost. So therefore, when the order quantity is small, the ordering cost is high. Okay, but let's say if we increase the order quantity, let's say every time we order 600. So every time we order 600 units, it means in total, we only need to order 2 times. Sorry, not 100, 1,000, 6,000. Okay, so if the order quantity is 6,000 and the annual demand is 12,000, so it means we only need to order 2 times. So the frequency of ordering reduce. As a result, ordering cost will reduce. So therefore, you get this curve like this. Okay, clear? Now, if we total up the blue line, this dark blue line and the light blue line, we will get the total cost. Okay, so the total cost is represented using this red line. Okay, trust me, if you find a value in this point plus a value in this point, you will get a point here. Okay, if you add the value of this point plus another value here, you will get this value here. So in other words, if you add up these two blue lines, you will get the red line. So the red line is the total cost line. So the total cost line here consists of the holding cost plus the setup or the ordering cost. Okay, so look at this total line cost. Look at this total cost line. It has a minimum point. So this minimum point corresponds to the minimum total cost. Okay, and if at this minimum point, if we project it to the x-axis, we will get the optimum order quantity, the best order quantity that will give us the minimum total cost. Right? So this is what we need to find. Because remember just what I said, we have to determine when to order and how much to order. So to answer how much to order, we will have to find this Q star here. Q star. Q star here is the best order quantity, the optimum order quantity, because it gives us the minimum total cost. Understand? Anyone does not understand? Anyone requires more explanation? Okay, now I proceed. So if you understand this curve, then you should understand all this. Okay, so first point it says by minimizing the sum of the setup or ordering cost and holding cost, the total costs are minimized. Of course, if we minimize setup costs or we minimize holding costs, the total cost will be minimized. Okay, and second, the optimum order size Q star, okay, is the best order quantity that will minimize the total cost. Okay, and then the third point I think is a repetition of the first point. A reduction in either cost reduces the total cost. Okay. Fourth point is the most important. The optimum order quantity occurs when the holding cost is equal to the setup cost or ordering cost. Right? If you look at this diagram here, this point correspond to this point, right? So this point happens when the holding cost intersect with the setup cost. In other words, this optimum order quantity happens when the holding cost is equal to the setup cost. So please remember this. This concept is later used to find Q star. So let's continue with the model now. Okay, so the model firstly in the model, you need to calculate the holding cost. Right, normally all this data will be given. So you must understand all this parameter. So let me explain. Q is the quantity lah. Okay, Q stands for quantity. So it means the quantity per order. Number of pieces per order or number of units per order. So it means every time you order, what is the order quantity? That is the meaning of Q. Q star is the optimum order quantity. It's the optimum number of pieces per order. In other words, it's the EOQ value. It's the economic order quantity value. So it means every time we order, what is the optimum number of quantities? That is Q star. Another symbol is D. D stands for annual demand. Okay, in units or in quantities for the inventory item. So I need to stress D is demand, but it has to be annual demand. Just remember this. It has to be yearly demand. It cannot be monthly or weekly demand. If you're given weekly, monthly demand, you have to convert it to annual demand because D is always yearly demand. So please understand this. Okay, S is representing setup cost or ordering cost. I already explained, setup cost is equivalent to ordering cost. So S is setup or ordering cost per order for each order. Understand? S is not the setup or ordering cost for the total year. It's the setup or ordering cost per order, means for each order. And H is the holding cost or the carrying cost per unit per year. Remember this, H has to be the holding cost per 1 unit per year. If it is not per unit or per year, you have to change it, convert it to per unit per year. Okay, if you understand all this, then let's look at how we can calculate holding costs. Oops. Okay, let's talk about, setup cost first, not holding cost. Let's look at how we can calculate setup cost. So annual setup cost is equals to the number of orders that we place every year times the setup cost per order. Simple formula, right? Makes sense, right? Annual setup cost is the number of orders that we have to place every year times the setup cost per order. So setup cost per order is given normally as S. Okay, number of orders placed per year is calculated as this. Annual demand divided by number of units per order. So it's just like what I said just now. Let's say the annual demand for an inventory item is 12,000. Okay, number of units per order means every time how many quantity we order. Let's say every time we order only 1,000. Okay, so if we use 12,000 divided by 1,000, we will get the number of orders that have to be made every year. Okay, so this is actually the frequency of making the order, basically it's the same. So you use the annual demand divided by the number of units per order, you will get the number of orders that has to be made or the frequency of making the order. So it's just D, D annual demand divided by Q. Q is the number of quantity, number of pieces per order, and then you multiply with S. This will give us the annual setup cost. Clear? Okay, if clear, then move on. Next, how do we calculate holding cost? Holding cost is calculated in a easier way. We just use the average inventory level times H. Remember just now I already explained, average inventory level is the order quantity, which is Q, which is the inventory level Q divided by 2. So this is the average inventory level. We multiply by H. H is the holding cost per unit per year. So if we use average inventory level times H, we will get the annual holding cost. Right, let's continue. So remember our objective is to find Q star. This is the optimum number of units that we have to order every time. Our objective is to find this value. So just now I said that this value happens when the holding cost is equal to the setup cost. Right? So look at here. So we make this as an equation. Setup cost is D per Q. I think you look at this better. I don't have to write. Look at this better. So D per Q by S is the setup cost equals to the holding cost. So when they are equal, we can solve for Q. Okay, so rearrange this, it becomes 2ds equals to Q squared H. So rearrange it again, Q squared equals to 2ds divided by H. And eventually we can find the value of Q star. Q star is just square root of 2ds per H. So please remember this. This is the formula that you have to remember. You will not be given an exam, because it's a very simple formula. So how we get this is from here. I already said Q star happens, the optimum order quantity happens when the setup cost equals to the holding cost. Okay, so we equate these two costs and we solve for Q, you get this. Okay, any questions so far? Quiet means no question. Okay, no question, then we look at one example. Okay, so this question says determine the optimum number of needles to order. Okay, so the inventory items are needles, needles. How many needles to order? So what is given? Given D, D is 1000 units. So D is what? Demand, remember? D is demand, demand of the item per year. So demand of needles per year is 1000 units. Okay, and given S is $10 per order. What is S? Setup cost. So S is a setup or ordering cost per order. Means for every order that we made, what is the setup or ordering cost? And also given H. H is $0.5. What is H? H is the holding cost. And it has to be per unit, for 1 unit for 1 year, per year. So please remember this. So if we know this, then we can easily calculate the optimum order quantity. So Q star, as I already said, is equal to square root 2 times D times S divided by H. Right? So 2 times D is 1000, S is 10, H is 0.5, which is 40,000. You take the square root, give us 200 units. So I hope you understand what is the meaning of this 200 units here. The meaning of this 200 units. This is the optimum order quantity. This is how much the company should order every time when it places an order. And in theory, it is also known as the economic order quantity, EOQ. Why EOQ? Because this is the best quantity, which is the most economic. That's why it's called economic order quantity. Clear? This 200 units is not the total quantity that the company should order every year. Please don't get confused. This 200 units is the order quantity that the company should order every time it places an order. So every time the company wants to purchase the needles, okay, as the raw material from the supplier, every time it should order 200 units. That is the meaning. Okay, so let's continue with this question. Let's continue with this question. D, you know already 1000, S is 10, H is 0.5, Q star is calculated as 200. So let us continue. Okay, next question. Determine the expected number of orders. So if every time we are only ordering 200 units, how many times we have to order? That is the question. Determine the expected number of orders. So how many times you have to order? Common sense, anyone can tell me? What is the expected number of orders that the company have to make? 5. Okay, very good. So as I said, it's common sense, right? Why 5? Because total demand is 1000. We need 1000, but every time we are only ordering 200. So it means we have to order 5 times. 1000 divided by 200, 5. So it means every year you have to order 5 times. So you have to make 5 orders every year. Okay? No question, Okay, no question, move on. Next question. Determine the optimum time between orders. So anyone can answer this? This is also actually common sense. You know, every time you have to order 200 units, and throughout that year you have to order 5 times. So what is the time between orders? Okay, so to answer this, you will have to know the number of working days per year. Okay, normally number of working days per year is given in the question. Okay, we cannot say that it's 365 because this is not the number of working days per year. We have to subtract the weekends, we have to subtract the leave and so forth. So traditionally, textbook like to use 250 as the number of working days per year. So we use the number of working days per year, which is 250 days, divide by 5, because every year we have to make 5 orders. So we divide by 5, we get 50 days. So it means 50 days is the optimum time between orders. So it means what? It means order will have to be made after every 50 days. Okay, clear? So let's say we order now, and then after the order has arrived, we wait for 50 days. After 50 days, we place the second order. And then after that, we wait for another 50 days, we place the third order. That's the meaning. It means the order has to be placed or made every 50 days. Okay, next question. Determine the total of the inventory. So, how? Total annual cost. Total cost of inventory is equals to what? Is equals to, already explain, total inventory cost is equals to the cost plus the setup cost. Okay, so it wants annual, total annual cost. No problem because everything is in yearly basis. Demand is per year, H is per unit per year, so everything is per year. So use this formula, holding cost plus setup cost or setup cost plus holding cost. So already explained. Setup cost is calculated as this, holding cost is calculated as this. So now it's just a matter of putting in the numbers into the formulas. D per Q times S, D is 1000, Q is this, it's the 200 units that we have calculated, because this is the optimum order quantity, times S is $10 per order, and then for holding cost is Q per 2 times H, so Q is 200, divided by 2 times H is 0.5, so if you calculate this, you will get $100. So this is the minimum, the most minimum or the most economic total cost, total inventory cost. Okay. Okay, sometimes if the material cost is given, sometimes only the material cost is given for the inventory, you can also even add up the material cost. Okay, using this uh, P times D. So P is actually the cost of the inventory per unit, okay, or the material cost per unit. You times with D, D is the total demand. So if P times D, you get the total material cost or the total product cost for that particular inventory. So if material cost is given, then total cost will be calculated like this. Okay, it's the same, but then you add this term here. Okay, only add this term if the material cost is given. If the material cost is not given, then the total inventory cost is just this. Okay, right. What time now? 12:30. Um, maybe I can stop here lah. Okay, maybe I don't want to go continue lah. I don't want to do it too fast lah. Okay, if we do it too fast, then we can finish the class actually in week, I don't know, by week 10, and then we can finish everything. But let's do it slowly lah, okay, for the sake of your understanding. So I stop here first, and then I will continue next week with the EOQ model, and then I will go into the other models, the POQ model and the quantity discount model. Right, so any other question before I stop the class? Okay, if not, then I stop here. Later, please remember to scan your attendance. 5 minutes from now, you can scan your attendance. So no question, then goodbye. Okay, goodbye for today. I see you on Monday. Okay, so bye bye.
Thank you, Doctor.
Okay, same to you. Bye.